Hi, I'm Daniel Ehrenberg. I work for a consultancy called Igalia, and I came here, I wanted to tell you all about TC39, and in particular, a feature that's in development for JavaScript, which is class fields and private methods for JavaScript classes. So first I want to talk about where JavaScript comes from. It didn't just fall out of the sky. The initial version was created by Brendan Eich, who was working for Netscape at the time. And he designed a simple programming language to look sort of like Java, but work in web browsers and be simpler for scripting. But from there, evolution became more driven by many different people. So JavaScript was cloned by Internet Explorer. And once there were two implementations that had to agree on things, the two browsers together with other language experts came together and formed a standards committee to design the future of the language. And that standards committee is called TC39, which is associated with ECMA. It's where JavaScript got its funny name ECMAScript from. So I'm a member of TC39, and so I'm participating also in the evolution of the language. The group TC39 meets every couple months in person for 3 days to discuss what should change in JavaScript. So we discussed language additions and also modifications to existing language features. And there are members that are both browser makers and large JavaScript users, like big websites, and also academic language experts and community groups. In addition to being open for new membership, you can also participate online. So we have a new description of what can be ways that you can contribute online to JavaScript, to the development of the language. So the way we make decisions is we do all of our development on GitHub. So it's all out in the open. If anybody wants to go in and say, hey, this feature seems to work a little bit wrong, we really like to get bug comments and things like that. And we have pull requests against the spec. Features are developed according to a stage process, where first a feature is introduced, and then the committee decides if we really want to put it in the final programming language. Then we nail down all the features of all the main semantics of the specification. And finally, once it's at that point, it's sort of passed off to implementers to try out in real JavaScript implementations. And once we have a couple implementations and full conformance tests, it can be put in the final language standard. So I wanted to walk through a couple examples of how this works. First with a smaller change, and then with a bigger change. So for a smaller change, in this change, I noticed that there were some features of regular expressions that weren't actually written down in the actual language standard. So namely, you can have \C in a regular expression, which is supposed to be how you note a control character. But if you use invalid syntax, then if you're not in Unicode mode, this is kind of obscure, then it will still interpret that as something valid, and it will make up other semantics for it. So it seemed like because three web browsers supported this semantics for a long time, all matching each other, that it would probably break the web if we change the semantics. So even if it doesn't make any sense, probably somebody is going to be depending on it because it's just been this way for so long. So in this change, I made a PR, and you could see there's just one file for the specifications. We have this spec.html, and it's written in a sort of custom elements dialect, Markdown mixed with HTML. And so the patch just sort of says this is what it would be. And the development was completely like a normal open source project because I posted one initial patch and added some people who helped, and then other people commented, oh, the way you did this was wrong, changes. Eventually, at some point, once this had developed somewhat, I went to TC39 and asked them, does this seem like a reasonable change? The committee accepted it, and one more step was writing test262 tests. So we have a test suite where all changes, or we try to make it so that every aspect of the language is covered by the test suite, so that whenever you're implementing JavaScript, you can run the tests against it and see if your implementation was correct. So once there were tests and verified that it matched existing implementations, and the committee signed off on it, then the patch was merged. So a bigger example is class fields and private methods. So you might know about ES6 classes, how you can do a class and then a curly bracket and have a class body instead of manually setting up prototypes and constructor functions and all that. In this proposal, well, there's an example on the next slides, but adding class fields gives a way to describe a fixed shape of a class, and in particular, once we have private fields and methods, it gives a way for a class to have internals that can evolve over time without breaking users. A lot of classes these days, they have fields or methods, properties or methods named with an underscore at the beginning. And library authors might be hoping, okay, nobody's going to depend on something that starts with an underscore. But the problem is they do. Even if the name is even more obscure than an underscore, even if you use symbols or something that's generated at runtime, it's happened again and again that projects like Node.js Core or frameworks or libraries have trouble changing how they work internally because they find that people are actually using these things that they intended to just be internal. There are a couple ways that you can do this right now. You can use weak maps, or you can use closures. The classic way to handle this is in your constructor, you have some lexically scoped variables, and you refer to them from methods. So you put the method on the instance rather than in the class. But both weak maps and closures have some performance cost, and they're also not as clean looking. They don't really look like ordinary code with classes. So in built-in, it both has better ergonomics and hopefully performance. So TC39 was hoping to put in private methods and private fields into the definition of classes in ES6. However, there were a bunch of issues that hadn't been worked out at the time. So the way the committee resolved that was, the committee's idea was, it's better to have some class features than nothing, to have some minimal classes that support some things, and then this can be used as a framework that we can add more things to over time. So since then, I've been picking up some of the work of trying to coordinate and write some of the specification text for the way that class fields and private methods work in future versions of JavaScript. So to go through an example, here's the definition of a custom element. I'm not sure if you all know the new custom element system, but now you can extend HTML element and and what this does, it's a little bit blocked, but basically once you define a class that extends HTML element, you can register it such that whenever you have a num counter tag in your page, it will actually turn into this thing that has this behavior that's described in the class. So here I have the definition of a counter, which has an instance variable x, which is set up by, on the constructor, it says this.x equals 0. And when you click on it and call this.onClick, it will increment x, and it will render will re-render itself. So on the next time that something is going to be rendered to the screen, it will call this render method, which sets the text content of the element to that incrementing counter. So this works. A minor improvement that we can make is if we add a public field definition for x. So this is a bit more convenient. Instead of setting up this.x in the constructor, we say in a somewhat more declarative way, all instances of this counter are going to have this x property, and it gets initialized to 0. So the hope with public field declarations, even though they're ordinary properties and they have dynamism, is that it will encourage programmers to define classes in a more consistent way, which could lend itself to better performance as well as being more readable. It's a nice place to put comments, or if you're using TypeScript, to put type declarations. Once we have private field declarations, this changes. You can add a hash before the name of the variable. So the hash is sort of like an underscore, except it really works. You cannot access this x outside of the body of the class. The only way to access x is in these methods that are in the class. So in the clicked method, increments it, and then render method reads it. The benefit of this is once you have your element, you can export this as a library, and nobody can accidentally depend on x. If you're using Shadow DOM in conjunction with this, it becomes a completely tight abstraction boundary. Then a third feature is private methods, where you can use the same hash syntax for methods as with this private clicked method. If you want to have some behavior that operates on private fields, maybe not all that behavior makes sense to export either. You may be calling it from multiple places. So private method declarations adds the ability to add this extra hash before clicked. So where are these features now? They're at stage 3 in the TC39 process. So that means that we decided that they're stable enough that implementers and users and programmers can start to actually rely on not having too many changes to them. It's sort of a fuzzy definition, but we hope that the major semantics are worked out at this point. So based on that level of stability, there are implementations in progress in V8 and JSC. These are the JavaScript engines that are used in Chrome and Safari. So as I said, these are developed on GitHub. What we do for large proposals, rather than doing them as pull requests against the main repository, we open up smaller individual repositories for them. So for this, we have this proposal class fields repository that the way these repositories are structured is that we include first an explainer. An explainer document describes the motivation for this specification, and it describes the major semantic elements of it. Then there's also spec text, which is sort of a fragment of the main JavaScript specification with inserted parts in green and there's deleted parts in red. Or if it's a whole new section, it's not really highlighted. But this allows people who might implement it in a browser, or somebody who might be wondering what the feature is, to read it. The spec text is often really hard to read. Often we have sort of spec text bugs that are lurking in proposals for a while before anybody notices, because it's impossible to run them. But it's important we get this right, because there are only so many people who are present at the meetings when we're discussing what the feature should be. So it's important to have a very clear written description so that everyone's on the same page. However, for a well-written repository, proposal repository, most people should only have to look at the explainer or other markdown documents that are there. So we have similar for private methods. Yeah, previously we had private static fields and private static methods and public static methods. At the last TC39 meeting a couple weeks ago, we decided that those things were sort of not quite ready yet. So it was demoted to stage 2. And now it's split off into a separate repository. Anyway, I'd really like your help from here, both for this proposal and for other proposals. TC39 needs more feedback from JavaScript programmers about what our direction should be, about the details of the different proposals. So a lot of these are implemented in Babel or TypeScript, and using those is helpful. There's also work to do in the Babel and TypeScript implementations for many language features that are proposed at TC39. A lot of our work is driven by bugs that are filed against the proposal repositories. So if you have any concerns with the way the proposals work, then filing bugs is a really effective way to get feedback to the proposal champion or to the committee. And generally, there's this document that you can find on the link. It's linked from the main page of the TC39 GitHub repository. This contributing.md, which describes how we work on GitHub, how new feature proposals are made. I think there's some more documentation work that we still need to do. But if you want to get started helping out with designing the future of JavaScript, this could be a good place to get started. Thanks for listening.